Hello there. To anyone who might be watching this, I just want to say that since nobody is watching these videos right now, I assume the topics are of no interest, at least either that or it could be the way that the channel view is laid out. That is, come on. See, I added this index, so I might not be really seeing what's going on. This here, if you look at this, you're going to click here, right? Probably first. And the last thing that I've just done is not visible here, right? It never is. So there's no way on this page to get to the last, what I've currently done. And so that could be possibly the reason why nobody's seeing or is aware of what I've been doing lately. So what I'm going to do right now, the only way to get there, besides making a link, is to go to Video Manager, and then click here. So I'm going to take this here, I'm going to edit it to change. Now, where do you think the settings are? Oh, they made a button for it. Never mind. I'm going to edit this one to show it in order manual. Newest to oldest. Allow embedding. I don't know if I want to allow embedding. What does it mean, allow embedding? You can embed a video. Well, if it's going to be ordered the wrong way, I don't think I want that. Okay, so now at least you'll see the most recent thing on the page, right? And the other thing is it's more convenient to use this index to browse through the videos, and pretty much it's not very well laid out the way it is. It's almost impossible to make it lay out in the way that I'd like. And what I'd like is at least for people to be aware of what's going on, and if they are aware and are obviously not watching them, then to try to think of something interesting to do. Now, I'd like to actually do more with this math stuff. There's something that I've been, of course, changing and improving on this program. And there's this theorem that I want to prove. And this has to do with computer graphics and things like collision detection and so on, vector for these, what do they call, vector sprites, for instance. And let's see, I started just as a test. Like the first step would be, now you'll notice by this view that some of these arrows are thick and some are thin. That's one feature I wanted. Um, the edit mode is now indicated. So if I go like this, it shows me that I'm in the path mode, so I won't get confused as to what mode I'm in. If I do this, I'm in the vector mode. There's a few modes, and I think escape gets me out, but it doesn't refresh. Let's see. If I'm in vector and I do this, I can't tell from that experiment. The thing I want to prove is this. It's not a formula really, but it's this code that I used when I was doing computer games, and the code we were busy and there was time. There were time constraints, and so I just used the code blindly without ever understanding it. And I'd like to understand how it works, or maybe make my own version of this formula. It's quite fast. It's very fast, and it determines whether two line segments intersect. Where is it? Sprite. This is not part of this project. Down here, I just grabbed this code off the internet from somewhere. And I have a general idea of what he's doing, but it's hard to read just as it is. You see it's tiny and very quick. X1, Y1, X2, Y2 represent the first point, second point, and optionally it returns the point of intersection. Now, this is a linear algebra thing, and I just want to prove this formula. Like, what's R1? What's R2? Like, I can see what this is, right? If A1, B1 were a vector, then it would be perpendicular to the first line segment, right? It's like the x's minus the y's, but one of them's flipped. Same for this one. I don't know why he's computing perpendiculars to the line segments, but he is. And then there's this C1, which is like what they call it, a determinant, and it's in this case it would be the determinant of the line from the I really don't know why he's computing this formula. This is something called a determinant, okay? It's actually in my first thing I wanted to show is that if you define two vectors A and B, and in this case those would be this and this, right? Two lines, sorry, they go on off to infinity. And I've defined them for convenience to be parallel with these. Then if you take this product, this times this minus this times this, which is called a determinant, if this was a 2x2 matrix, if that comes out to 0, hey, I don't know where I cut off on the last one, but there was a mistake or an omission in here. I got messed up trying to show the equivalence between this way of describing a straight line and the parametric form. How these A's and B's would relate to A's and B's if you use this method. Okay, this is another way of describing a straight line. What I had omitted was the C here, the extra constant, so that's there if a line doesn't pass through the origin. So x equals 0, y equals 0 is not an element of the solution set for this. Okay. Now, it's easy to show that this representation and this representation within this representation and this representation, this equation of a line being it's one or the other of the 2 points that are known to be on the line. Plus some parameter and then it's the difference of those two vectors, p1 minus p0, or the other way around. The signs don't matter. Oops. Is that right? Yeah, that's right. Let's put that there. That's the parametric form is a known point on the line plus some varying number times the difference between that, the difference between the vector difference between these 2 points, which is the a vector parallel to the line. Okay. Now I just define those as ax, ay, and bx, by. The ax, ay correspond, either 1 to 1 or maybe with a minus. It takes on the role of a -1, but it doesn't matter. It's arbitrary. They have the same meaning. They correspond to the same meanings as these differences. And the importance of showing that, or knowing that those 2 things are true, is because I think it's a pretty well-known fact by anybody who's studied algebra, even in high school, that 2 lines defined this way are parallel. That is, they don't intersect when this here difference is 0. One is with A's and another is with B's. If this difference is 0, then the lines are parallel and they never intersect. So that's one thing that I want to prove. And then I want to see how that relates to whatever this guy is doing here in this very handy equation, which returns to you not whether 2 lines intersect, but 2 line segments, They might be anything that's not parallel is going to intersect somewhere. But if they're a limited length, then to figure out if they intersect or not, well, it's not that hard. I think that this is probably more difficult than what I would come up with. Because I can compute the intersection point in like 2 lines, right? And I know the range of both of the segments, their t values, right? By the parametric form, t goes from 0 to 1 to take you from 1 to 1 or the other 2 points on the line. And if the point of intersection is not within the range 0 to 1, then they don't intersect. I can't see why this isn't even a shorter thing than it already is. Anyway, I'd like to do that, and then I'd like to show you a couple other neat things to do with dot products and stuff, like collision detection, and ricochet and that sort of stuff. Okay, I'll try and glue this and the first part together, see what I come up with. See ya.